So welcome back to the channel guys. Hope you are doing extremely well and this is your very own mass coder this side. Welcome to linked list lecture number 24, right? So in few videos, about 6 to 7 videos, the linked list series will ever end and you will be able to solve every advanced concept of linked list as well. Okay. Now the question for the day is find pairs with given sum in doubly linked list. The question says that it has provided with your doubly linked list. Of course, you have the head of it, right? And now you will have to tell me the pairs of it that are equal that are actually summing up to target equals to 7. Given that the doubly linked list is sorted, it has been given in the problem description that doubly linked list, or I can say DLL, is sorted. As you can see, 1 2 4 5 6 8 7 6 8 9 is actually sorted. How will I solve it? How will I solve it? Now if the same question was given to me in an array, how could I solve it? Suppose the array was 1, 2, 4, 5, 6, 8, 9. This was the array given to me and I wanted to find the pairs which are actually summing to the value of target equals to 7. How will I do it? Now there are two cases of do it. I have to find pairs, right? I have to find pairs. Now here also there is a brute force and an optimized solution. The brute force approach on the array says that use nested loops, right? Use nested loop. That is, run your I from 0 to n minus 1 in the outer loop and run your j from I plus 1 to n minus 1 in the inner loop. And if array of I plus array of j equals to your target sum, that if this is equals to this, in that case answer dot pushback value of array I and arrj in a separate pair, right? In a separate pair. That should not be a problem. The time complexity is a problem. What is the time complexity here? It is O of n square. It is O of n square. But is it achievable in the case of doubly linked list as well? Can I do the same case? Can I do the same algorithm on doubly linked list? Yes, I can do. Why I can do? Because doubly linked list actually helps me traverse next also and previous also. So what will I do? For the given linked list, let me mark it here only. For the given linked list, I will keep my head here, right? Now I will traverse until my head is not equals to null, right? Until my head is not equals to null, I will keep traversing. My head is initially here, then I will keep a node here, I will keep another node here. My head is here, this will be my ith node, this will be my jth node, and j will now traverse up till and unless j is not equals to null. J is not equals to null. Let me write it down for you. So my approach will be, head is at head, right? Now I will say while head. What will I do while head is there? I will say uh, node star j equals to head next, right? Now while j, that is while j has not been equals to null, what will I do? I will say if head data plus j data equals to sum, in that case equals to sum, in that case answer dot pushback, same, head data and j data, head data and j data, right? If it is not same or anything else, I will just say j equals to j, and that is explore another case, right? This is for the continuation of the loop, and after this while loop ends, I will say head equals to head next for the next set of pairs, next I, right? So virtually my head is equivalent to my I, and j is equivalent to my j. The problem here is the same, the time complexity. What is the time complexity? O of n square, as it was above, right? Because algorithms are almost same, right? It is using it is using integers to move forward, and it is using the pointers to move forward. There is not a problem there. The time complexity is a problem. Now, can I optimize the solution in an array? How? So let me copy down the array before. So the array given to me is 1, 2, 4, 5, 6, 8, 9. The properties of this array, the most important property that I am going to use is the sorted nature. And because I wanted to find the sum, that means I am actually trying to link it something to 3 sum. It is a famous problem. I have already solved it on YouTube and I will attach the link in the description. So please make sure to watch it before. So what will I do? I will keep a pointer here. Let's say I pointer here. I will keep a pointer here. Let's say j pointer here. Right? My current sum is My current sum is 1 plus 9 equals to 10. I want a sum equals to 7. I want a sum equals to 7. Now three cases can occur. Sum equals to target, right? Sum less than target, right? And sum greater than target. Sum greater than target. I want the case of sum equals to target. Suppose this occurs. If sum equals to target occurs, I can simply say that answer dot pushback, same array of I, array of j, right? Answer dot pushback, right? After that, I will say that increment your I and decrement your j. If you're not able to understand why these steps, just give me a second. If sum is greater than target, first let's discuss sum is greater than target. That is the case of 10 here. 10 is greater than 7, right? Now, I have two options. Either my I can move forward or my J can move backwards, right? There are only two options to traverse. There are only two options to explore more. Now, if I move up, I move forward. If my I move forward, that is I'm going forward in an increasing array. Because this array is ordered, this is an increasing array. And because this array is increasing, if I move from left to right, I'm actually increasing the value of sum. I'm actually increasing the value of sum. But I don't want to increase the value of sum. I actually want to increase the value of, decrease the value of sum. So if my j move forward, that is 9 to 8, you can see the sum is actually dropping. So in that case, j minus minus. And similarly, if sum is less than target, I want to increase the sum. I want to increase the sum. That is, I will move my I forward. That is I plus plus. Now the question is, up till when will this loop go? Up till when will this loop move? So my answer to that is while my I is less than j. While my I is less than j. Why? Because if my I is less than j, that means if my I is less than j, that means that I am actually at a partition point where these values are actually occurring only once. That is, I'm not forming double pairs. So I'm not forming double pairs, right? This is the only case. I should not be equals to j. I should not be equals to j to form the pairs. I cannot. I don't want to choose a same value twice, right? Same value twice. That is the reason for me. So I will just use this approach in my doubly linked list. How will I use it? Now, for that, I will have to create a head. So my head is given to me. I will find my tail using it. How will I find my tail? First, my tail will be equals to head. And now while my tails next is not equals to null, I will just keep traversing it. Tail equals to tail next. This has already been discussed, so I will not waste time visualizing it again. So if you do not know how, please follow the playlist and you will get your answers correctly. While tail next is not null, tail equals to tail next. So now in the linked list, 1, 2, 4, 5, 6, 8, 9. My head is actually here. My tail is actually here. This is my pointer 1. This is actually representing my I here in the 2-pointer approach, and this is actually representing my tail j here. Now what will happen? As discussed, while my head is not equals to tail, that is they are not pointing to the same node, and my head's next, my tail's next, that is tail does not pass it, tail does not come before it, tail's next is not equals to head, that is tail is always on the right side of head. Now what will I do? I will calculate the sum. So sum equals to head data plus tail data plus tail data, right? Three cases. If sum equals to target, I will say pushback. I will not write the whole operation, I will just code it down. I will just push back, and then head equals to head next, head equals to head next, and tail equals to tail previous. Tail previous, this is where doubly linked list is actually coming up, because j minus minus means I am moving towards the left, that is going to the previous operator. Tail equals to tail previous. Other operation is if sum, this will be else of course, else if sum less than target. If sum is less than target, that means I have to increase the head value. So head will be equals to heads of next. And else operation means sum is greater than target. So tail equals to tail previous, that in that case, right? And at the end of the loop, you will have your answer which you have pushed back, and you can simply return them. You can simply return them. What is the time complexity? The main objective for this approach was time complexity. So if you discuss it here, you are actually traversing. My I will only go for these operations. I plus j are only exploring these operations only once. So it is actually equals to O of n. And the space is also O of 1, right? So it is actually an optimized version. Similarly here, O of n and O of 1. right? That is why we use this approach. Now it is time for you to see the code for it, and I hope the approach was clear to you. If not, you know where to comment, you know where to DM me. My links, my social media handles are present below only. So please don't forget to DM. Okay. Alright guys, so here is the coding section. But before beginning with the code, I would like to request you to please subscribe to my channel, because your really gives motivation, right? Moving forward, first I will create a tail node, because I have the reference to head, but I will create a tail node also. Initialize with head only. Now while my tail next is not null, what will happen? Tail equals to tail next, right? Move the tail node to actual tail node. After that, create a vector of pair of int to store the answers. Right now my loop will move until my head is not equals to tail, that is they are not pointing the same pointer, or the tail has not surpassed and tails next is not equals to head. Now moving on, my int sum equals to head data plus tail data. Three cases arise if sum equals to target. In that case, pushback will occur, right? So answer dot pushback the head data with the tail data, right? And after that, head will move to head next, and similarly tail will move to tail next. Tail equals to, let me zoom it in a little, yeah, tail equals to tail next, right? Other cases, else if sum is less than target, if that means I have to increase the sum, that means head will move forward, head equals to head next. And similarly in the else case, I have to decrease sum, so tail equals to tail previous, tail equals to, and it will be previous here, sorry for the typing mistake, tail equals to tail previous here also, right? Now I've, after the while loop, I can simply return my answer and it should work fine. Let us try to compile and run it. So as you can see, it is running fine for the submit button. For some reason it was taking a lot of time in comparison, so I didn't run it. Okay, so it is getting submitted actually correctly. So thank you for watching, and we'll meet in the next lecture. Stay tuned, keep watching, and if you're not yet subscribed, do click the button. Okay, thank you, have a nice day.